Hello, this is Mrs. Taylor, and I'm going to walk you through the logarithmic properties and how to apply them. So the three properties we're going to use in class are the product and quotient properties and the power property. The product and quotient properties are for multiplying and dividing. That's why they're called product and quotient. If you have a product here, m times n, the rule is that you can expand this logarithm into two logarithms that are being added together. So you separate the two products, m and n, from each other by adding them separately as logarithms. And then division pretty much works the same way. It's just subtraction. So if you have two things being divided here, then you can just expand to two logarithms and subtract them. And then the power property states that if I have an exponent here, so if I have log base b of m to the p power, that exponent can then be moved to in front of the logarithm and then multiplied by the logarithm. So these three properties are properties that I can use to manipulate logarithms so that I can solve equations. So it's just a way of rewriting to make solving easier. So let me show you how to apply these properties. In the first example, the directions say expand each logarithm, and what that means is they want you to take these properties that I just showed you and apply them to take one logarithm and expand it into two or more. And so let's wait on number 11. Let's start with number 12. All right, number 12 is log base 9 of x times y times z cubed. And this is a product, so you're going to use the product property, which states that if the numbers are being multiplied, you can separate it by addition. And so that means that I need three logarithms, one for the x, one for the y, and one for the z. So I'd have log base 9 of x plus log base 9 of y plus log base 9 of z cubed. But this 3 here is an exponent, which means that I'm also going to use the power property, which states that I move the exponent to in front of the logarithm. So the resulting expression I would have after I expanded is log base 9 of x plus log base 9 of y plus 3 log base 9 of z. And that 3 was the exponent of z in the condensed version of the logarithm. So these two logarithms will be equivalent. This is the expanded form. Division works the same way. So 13 log base 8 of x to the 4th over y to the 6th. I separate those by subtraction, like the division or quotient property states. And so it would be top minus bottom, log base 8 of x to the 4th minus log base 8 of y to the 6th. And remember, exponents, 4 and 6, they move out front because of the power property. So the result would be 4 log base 8 of x minus 6 log base 8 of y, because it's division, which is subtraction, and exponents move to in front of the logarithms. Number 11, the reason why I skipped it is because it adds in an exponent property or exponent rule that you need to remember. Remember that if I raise a fraction to an exponent, both the top and the bottom get that exponent. So if I rewrote this, it would be log base 3 of a to the 6th over b to the 36th. And then it becomes just like number 13, where you separate into two logarithms or expand into two logarithms with subtraction, and then move the exponents out front. And then number 14, you'll have to recall what we learned about radicals. So if I have a square root, I can convert it to an exponent, making it a fractional exponent. And so the rule was denominator root, numerator exponent. And we learned that square root is the same thing as x to the 1/2. So really this is like number 12, where I'm multiplying. Both products have an exponent. The z has an exponent of 3. The x has an exponent of 1/2. And so when I expand that, I expand with addition and then move the exponents to the front. Now, the way they've written the logarithm here, they put the 2 on the bottom, but you could also write it as 1/2 out front, log base 4 of x. So both forms are acceptable, both forms are equivalent and correct. And so either you can just put the 2 on the bottom, or you can multiply by 1/2 out front. Now, not only will you be expected to expand, but also condense, which means move in the opposite direction. So you'll have an expanded logarithm, and you'll be expected to condense it to a single logarithm using these properties. So for example, number 1, I have addition, so that means I need a product. And when I condense it, not only do I need to remember to do 11 times 7, but I also have these numbers out front, this 3 and this 6. And so I have to remember the power property, which states that those are exponents of your number. So this logarithm here could be rewritten as log base 6 of 11 cubed. This logarithm could be log base 6 of 7 to the 6th. And then once I condense it to just one logarithm, I would just multiply 11 cubed with 7 to the 6th together. So the resulting logarithm would look like this. And yeah, we can simplify these further and actually evaluate 7 to the 6th times 11 cubed, but you don't need to for purposes of these exercises. You just need to condense it down, which I did. So number 2, instead of just one product, I have 3. And so pretty much same rules. This would be x times y, and then this 3 out front would become the exponent of z. So this would be your resulting logarithm, y times x times z cubed. And then same thing with number 4, all addition, so you just put it all together. Number 3 is subtraction, which would be division. And the only thing you have to remember is anything before the minus sign goes on top, and anything after the minus sign goes on bottom. So my result would be x cubed on the top and y squared on the bottom. And that's how you would condense logarithms. And the last property is the property that states that if the base and the number are the same, then your logarithm simplifies to just 1. And it's intuitive because if you convert this to exponential form, it would be b to the first equals b, which makes perfect sense. The only way the base and the number could be the same is if your exponent was 1. And so where this comes in to play is when you have expanded a logarithm and you end up with a logarithm where the base is the same as the number. And so if I expand this logarithm, it's multiplication, so I would add, and then I have exponent of 2, so I need to remove that out front. And so once I expanded, the result would be this. Log base 6 of 6 plus 2 log base 6 of x. And then I need to remember that log base 6 of 6, because of this property, equals 1. And so I can replace this and simplify it to just 1. And so my final answer would be 1 plus 2 log base 6 of x. So those are the 3 properties of logarithms we're going to work with in this class. And I hope this video helped you catch up.